Hello dear friends of our YouTube channel, Learn Maths, Ika Imrani. Welcome back you to our channel where we are going to deal with integration. What do you understand by integration, guys? Integration is an opposite of differentiation. Okay? For polynomials, integration deals with ascending in the powers of x, while differentiation deals with descending in powers of x. Now, let's look at the integration rule, which is basic. Basic integration rule. This is the formula to follow when integrating polynomials. The integral of x for n dx is equal to x to the power of n plus 1 by n plus 1. Then we add the constant of integration. This constant can be any number. Now, let's have a simple example. The integral of x squared dx is equal to x power 2 plus 1 divided by 2 plus 1 plus c, and this is x power 3 by 3 plus a constant of integration. The next example, let's have the integral of x power 5 dx. This is x to the power 5 plus 1 by 5 plus 1 plus c, and this is x to the 6th power by 6 plus a constant of integration, guys. But here is a note. When dealing with the integral of 1 over x dx, what is this? It's clear that it's the same as x to the minus 1 power dx. And this does not follow this formula here. Because we know that the derivative of ln x is equal to 1 over x. As you said, integration is the inverse of differentiation. That's why the integral of 1 over x is only the natural log of x. Here, this is the natural log of ln of x derivative by x dx. Here is ln x. Okay. Here we have 1 over x dx, and this integral gives the natural log of x plus c. We are going to see basic integration properties. The integral of f of x plus g of x with respect to x, this is the integral of f of x dx plus the integral of gx dx. The second property is when having a constant times the integral of a constant times f of x, the integral of a times f of x. This is the same as taking a out of the integral sign times the integral of f of x dx. Okay, let's have two examples. 1h. Okay, what is the integral of x squared plus x dx? This is the integral of x squared dx plus the integral of x dx. Because all of these are polynomials, we add 1 to the power of each, and the concept will be unique. Here is adding 1 to these two, we have x power 3 by 3 plus, here is assumed to be 1. That's why we are going to add 1 to this one to be 2. Here is x squared over 2 plus a constant of integration. Hope this is clear as you see. Now the next is example of 6x to the power of 3 dx. As you saw, we take out the 6 as you took out a. Here is 6 times the integral of x to 3 dx. This is 6 times x. We are going to add 1 to the 3 to be 4. X to 4 by 4 plus c. By 2 by 2, we have 6 over 2 x power 4 plus c. You can have some other examples. It doesn't matter. Now, let's continue with integration techniques. Let's continue with integration techniques. Integration techniques are of various kinds. Let's start from integration by substitution. The integration by substitution, this is where we find the integral by finding the derivative of a special function in the function you have been given. For example, we replace a special function by u and then find the derivative of u. Finding the derivative of u, this is expressed in terms of dx, and hence we find dx in terms of du. Okay, let's have one example. The integral of cosine of ln x by x dx. As you see here, we know cosine x, but here is cosine of ln x. This ln is going to be assumed as 0. So let u be ln x. As you saw it here, the derivative of ln x is 1 over x. Let's find du is going to be 1 by x dx. What is dx in terms of du? Dx will be equal to x times du. We cross multiply x to the left. Now, the integral becomes cosine of u by x times x du. You see, here we can simplify this x and this one to be the integral of cosine u du. Because you have cosine u, the integral of cosine u, as integral is an inverse of the differentiation, what is the derivative that gave cosine? See, that is the derivative of sine. Okay? Here is the integral of the derivative of sine x. The derivative of sine x. So, because derivative is inverse of the integral, here must be having sine x. Hence, the integral for cosine of ln x by x dx is equal to, here is u, here is u, and here is u. This is the sine as u is ln x of ln x plus a constant of integration. The next example we are going to have is the integral of exponential 3 cosine 2x times sine of 2x dx. What is that integral? Here we have sine 2x, this is not special. Here we have exponential of 3 cosine 2x. Is that special? I hope it is. How? That is because we know exponential of x, e to the power of x. What is it? Now, we're gonna let u to be 3 cosine 2x. Du is given by the derivative of this, because there is a constant derivative and differentiate this. Differentiate cosine. We start by differentiating this, but the derivative of cosine, you know, is minus sine. That's why here we have minus 2, the derivative of the x, that is 2, the derivative of cosine, that is minus sine 2x dx. Du here is minus 6 sine 2x dx. The question is, what is dx? What is it? Dx is going to be du by minus 6 sine 2x. Now, we are going to replace this value and dx by this. Here is example 2. Now we have e to the power of u or the x's times minus, sorry, here is sin 2x times minus 6, sorry, minus du by 6 sin 2x. We can simplify this sin 2x and this to stay with minus e to du by 6 du. Following this property here, that minus 1 over 6 will be taken out of the integral sign to be the integral. Here is minus 1 over 6 times the integral of e to du. The exponent of x, the derivative of e to the x, stays as it is. It's also the derivative of, it stays as e to the x. That's why this will be minus 1 over 6 exponent of u for c. The question is, what is u? U was assumed to be 3 cosine 2x. So, the integral of e to 3 cosine 2x times sine of 2x dx is going to be minus 1 over 6 e to du. U is 3 cosine 2x, then plus a constant of integration. The next question I want to do is, but they'll be given as exercise. The next questions are this. Exercise evaluate. The integral of e to the power of x times cosine of e to the power of x dx. This is a. B will be the integral of x squared exponential x power 3 dx. The next one, C, will be the integral of e to the x minus x to the power of e dx. I'm gonna just show you how this integral will be computed. You are going to assume this e to the x inside cosine to be its derivative will never change. Okay? That is the same as here. You are going to let x to the power of 3 to be here. Its derivative will be 3x squared dx. Okay? That will change nothing. The next is exponential of x. This its integral doesn't change as its derivative does not change. Okay? Now, what about this? X to the power of e. Remember, this e is a number. That is 2.718, something like that. So I want to find that this is e to the x minus x to the e plus 1 by e plus 1 plus c. You need to find this. And this is going to be, what is this? It's going to be 1 over 3 e to 3x, sorry, e to x squared plus c. But this, you show it will be the sine of e for x plus c. Here we hit one of the techniques of integration, guys. And one more example is, let's solve this example together. It's about the integral of x power 3 divided by x minus 1 power 2 dx. Okay, as I told you, we deal with special functions in a given function. Okay, we are going to let the denominator, this stuff, inside the parentheses to be here. Now we have, let u be x minus 1 du will be the same as x. Because here we have x power 3, we need to express x in terms of u. That's why here, as u is x minus 1, our x will be u plus 1. This minus 1 will be added here to the plus. Okay. Now, let's replace. We are going to replace x by u plus 1 and x minus 1 by u. Here is u plus 1 for 3 divided by u for 2 du. This is the integral of, as you see, here we have u plus 1 to the power 3. We know a plus b power 3 This is a power 3 plus 3a squared b plus 3ab squared positive b power 3. That's what you are going to do here. You will be replacing a in one place b. Here is u power 3 plus 3u squared times 1 plus 3u times 1 power 2 plus 1 power 3 divided by u squared du. I can take this u power 2 here above so that its power sign will be 22 minus. Here is the integral of u to the power minus 2 into u power 3 plus 3 u squared plus 3u plus 1 du. This is going to be the integral u power minus 2 times u power 3, that is u, plus u power minus 2 times 3u to the power 2, that is only 3, plus u times this will be 3 u to the power minus 1 plus u to the power minus 2 du. Okay. The special thing is here only. Otherwise, we can add 1 to the power of each. Now, this is, here is a power of 1. That's why we are going to add 1 here. Okay? This is u to 2 by 2 plus 3. When dealing with this, take the 3, we be taking 3 out, and instead with integral and derivative, there will be only, here is 3u plus, let's have this, add 1 here, we have u minus 1 to the power minus 1 divided by minus 1 plus, let me here write the integral of 3 by u du. This is u power 2 over 2 positive 3u minus 1 over u because of this minus to the power plus, let's have 3, sorry, 1 over u du. This is u squared over 2 plus 3u minus 1 over u plus 3, as I told you, this will be in the form of the integral of 1 over x dx, which is ln. This is going to be ln u. We take this minus, this also divides because u cannot be minus plus. So, the given integral x power 3 by x minus 1 or 2 greater or 2 dx, we are going to replace u by x minus 1. This is x minus 1 over 2 over 2 plus 3 into x minus 1 minus 1 over x minus 1 plus 3 into ln of x minus 1 plus the constant of integration. That's how it is. Okay. Can you have another question or addition? No, I don't get that. Oh, we can try it. Okay. Let's have another question. This is example 4. Here was example where integrate exponential 3x dx. Remember, we are dealing with integration by parts. Sorry, integration by substitution. Assume this to be u. Let u be 3x. du is 3, the derivative of x is dx. Now, find dx. This will be 3 du by 3. The integral will become e to du times du over 3. This is, let's take out d3 here. It will be 1 over 3 times the integral e to du. As I told you, this does not change. It doesn't change. Here is 1 over 3 times e to the u plus c. So, the integral exponent of x dx is equal to 1 over 3 exponent of 3x plus c. In other words, let's have an note here. The integral of e to ax plus b dx is given by 1 over ax plus b derivative. This is the derivative of x plus b times exponent of ax plus b plus c. What about cosine and sine? They are of the same type. So, let's have example 5 here. The integral of cosine 5x dx. As you see, this 5x will be assumed as u. We let u to be 5x. Du is going to be 5 dx. We need to find dx in terms of du. This is du by 5. Okay? Now, we have integral of cosine of u times du over 5. This is 1 over 5 integral of cosine u du. So, this is 1 over 5. The integral of cosine, that is sine 5u plus c. Hence, the integral of cosine 5x dx is equal to 1 over 5 sine our u was 5x sine 5x plus c. Okay, I want you to try this. Try the integral of sine 5x dx. Okay, let's jump to integration of rational functions. Integration of rational functions. there will be the integral of the form hx by ds. Okay. The first thing you're going to see is if the derivative of the denominator can be expressed in terms of numerator, that is s1. The derivative of gx can be expressed in terms of hx. This is to say gx can be a number n times hx. This is what we are going to do. Let's have a small example. The small example is the one you had here. 1 by x dx. We have seen that the integral of 1 by x dx is ln x plus c. Okay? Now, this was seen by taking the integral u prime of x by u of x dx. When the derivative of the numerator gives a number times the numerator, the integral becomes the natural log of the denominator. That's it. Plus a constant. Let's have some other two examples. Example 2. Here is 1. 2. The integral. Let's have 2x minus 6 divided by x squared minus 6x plus 10. Let me have from here dx. You see, look at this denominator. What is the derivative of this denominator? The derivative of x squared minus 6x plus 10. This is going to be 2x minus 6. Since this derivative equals to numerator, the integral will be a natural log of denominator. Now, the integral of 2x minus 6 by x squared minus 6x plus 10 dx is equal to the integral of the derivative minus 6x plus 10 derivative by x squared minus 6x plus 10 dx. And this, the integral of 2x minus 6 by x squared minus 6x plus 10 dx is, since this is a natural log of x squared minus 6x plus 10 Then we add the constant of integration, that is direct integration, even if it can also be an integration by substitution. Let's continue with another example. I want to remind you the thing I want one of you to share this life. Remember to subscribe to this channel. If you have any other question, please write it in the comment section so that the next time we'll be dealing with the question. Okay? The next question to this is about, as I told you, let's even continue this question by integration by integration by substitution is here. Other alternative. The integral of 2x minus 6 by x squared minus 6x plus 9 dx. This can be computed by letting you will always assume the numerator to be used to be x squared minus 6x plus 10. The derivative of this will be 2x minus 6. Remember to multiply the x. And what is going to be done now is to find the x. The x will be given by du divided by 2x minus 6. So, let's go now. We have 2x minus 6 divided by u, because of this was assumed to be times dx replaced by du over 2x minus 6. You see, I can simplify this and this. This will be, here is 1 over u du. This must be a natural log of u, because the derivative of u with respect to t, that is 1. This is ln of u plus c. Hence, the integral of 2x minus 6 by x squared minus 6x plus 10 dx is going to be the natural log of x squared minus 10x plus, so minus 6x plus 10. Then add a constant of integration. The second one is about, let's talk about the integral of tan x dx. Let this be the next example to that. Yes. Example 3. We already know that the tangent is the ratio of sine x and cosine x. This is what we are going to write here. Here is sine x divided by cosine x dx. Okay. Do you think the derivative of this denominator will be a constant times the numerator? Yes, I guess. Yes. Let u be cosine x. You know the derivative of 0, which is the derivative of cosine. The derivative of cosine x, that is minus sine x. Remember to multiply the x. So look for du. dx is all. This is going to be du over minus sine x. Now let's continue with the question. We'll be writing sine x divided by u because we have assumed u to be cosine x times dx is going to be replaced by du over minus sine x. As you see here, I can simplify this sign and this sign, and I'll stay with the integral of 1 by minus u du. Because here is minus, I can take it out of this integral sign today, minus the integral of 1 over u du. Now, what is this integral? Look, it's the same as this. It must be a natural geography. Now, we have this is minus 1 of, minus ln of u plus c. Therefore, the integral of tangent x dx is equal to minus ln, what is u? Our u here was assumed to be cosine x plus the constant of integration, guys. I'm going to give you some examples, and these examples will be done by you to make sure that you have understood the lesson. Let me give you this as exercise. I don't want you to evaluate. A, the integral of x plus 1 divided by x square, here is square plus 2x plus 3 for 2 dx. B is about the integral of x by the square of 1 minus x square dx. C is the integral of x square by 2x power 3 plus 5 to the power 3 dx. D is the integral of x plus 1 by plus 2x plus 5 power 3 dx. All of these are integrals whose denominator can be expressed, whose derivative of the denominator can be expressed as a number times the numerator. Let's hope you try all these questions. The second S is about the numerator being expressed being not expressible in terms of the derivative of the denominator. Here you have more than one case. When the denominator is bigger or equal to the numerator, the power of denominator, the power of numerator is bigger or equal to that of denominator. What we do here is to do along the division. We do along the division. Okay, let's go with an example. Let's have an example. Example 1. A. Let's have x by x plus 1 dx. Okay. We can do this by assumption. Because here is 1, we can add 1 here and subtract it. Okay? Look. Let's add 1 and subtract it. Divide by x plus 1 dx. This is, do it like this. Divide by x plus 1 on each element. Either x plus 1 or 1 minus 1. Here is the integral of 1 minus 1 over x plus 1 dx. This is the integral of dx minus the integral of 1 over x plus 1 dx. We saw that when the derivative of x plus 1 gives this stuff on numerator, the integral becomes the natural log. So, here because integral is the inverse of derivative, this d will cancel the integral sign to stay with x minus. Because the derivative of this is 1, this must be the natural log of x plus 1. Do not forget to add a constant of integration. Let's have the next question. Okay. Question B. Let's have x power 3 divided by x minus 1 dx. Because other case will be later after this example. Now, as you see, the power of numerator is bigger than that of denominator. That's why we are going to do a long division now. Okay. X power 3 divided by x plus 1. Here we can have x squared. X squared times x, this is x power 3, but it must have minus. Okay? X squared times 1, that is x squared. That's why here we are going to subtract x squared. This will cancel this to stay with minus x to the 2. Okay. Here is minus. Means the stuff that will be multiplying here must be minus, so that when it comes here, it becomes positive. So we need to take here minus x. Minus x times x, that will be minus x squared. When that comes here, it will be x squared. This minus this times this, that is plus x. That's why these two steps with x power 2 will be divided into 0. Now, here we stay with x. Because here is x and here is x, we need to add 1 here. 1 times x, that is x. When it comes here, it will be changing the sign. Okay? And 1 times 1, that is, what is it? That is 1. When it comes here, it will change sign to negative. So, we have minus 1 as the remainder. Therefore, the integral of x to 3 by x minus 1 dx is the integral of this half, x squared minus x plus 1 dx, add the remainder, minus the integral, the remainder is 1 by x minus 1 dx. This is going to be, consider the powers and add them 1. Add 1 to them. Here the power is x squared. Adding 1, we're gonna have x power 3. Here is x power 3 over 3 minus, here the power of x is 1, add 1 to 1, that is 2. This is x to 2 by 2 plus the derivative of constant is that constant times x. Here is 1. 1 times x, that is x. So minus, what is the integral of reciprocal of x minus 1? Having this x minus 1, its derivative is 1. That's why the integral will be the left log of x minus 1. And then we add the constant of integration. Less of everything here is square. I do want to remind you to subscribe to the channel. Share the channel, share the live, subscribe on it to grow my channel faster. Let's continue with examples. Our class will continue next time. Before continuing with examples, I want you guys to these formulas. Formula 1. The integral of 1 by x squared plus x squared dx. Let's talk about it for a while. We know trigonometric identities. Let me remind them to you. We know that sine squared theta plus cosine squared theta, this is 1. That's why sine squared theta is 1 minus cosine squared theta. Okay? This is 1. And cosine squared theta may be written as 1 minus sine squared theta. This is identity 1. Identity 2, we know sec squared theta is 1 plus tan squared theta. And for this, tan squared theta is equal to sec squared theta minus 1. We need one to take about these two formulas. Okay. When having something for 2 plus any number for 2. We can use the identity this one. Okay, let's go with this question. Now, to deal with this, we assume x to be the square root of this number, the square root of a equal to, that is a, times the tangent of u. Okay? Now, find the derivative. The derivative of x, which is the s, will be given by a times the derivative of tangent, that is 6 squared u and half du. Okay? Yes. So here we are going to replace x by itself and x by s. That's where we have the integral of 1 by x is this, here is a tan u for 2 plus a for 2. dx is a sec squared u du. Now, this is the integral of a sec squared du by a squared tan squared u plus a squared du. This is equal to the integral of a sec squared u divided by, let's factor by a squared, because here is a squared and here is a squared. Let's factor by a squared. This will be 1 plus tangent squared of u, then du. Here we can simplify this a and this 2 to stay with a on denominator. Now, this is going to be, because a is a constant number, let's take it out of integral sign. Here is 1 over a times the integral of sec squared u by, we know sec squared of u is equal to 1 plus tan squared of u. Here 1 plus tan squared of u will be, let's replace theta by u. Here u, here u. This will be sec squared u du. So we need to simplify this and this. Okay? This is 1 over a times the integral of du. This is going to be u over a plus c. So, having this, we have u, but here we have tan u. This means we need to find u as a function of x. Okay? Since x is a tan u, this means tan u is equal to the length of x and l. U is going to be tan inverse of x over a. That's why the integral of 1 over x squared plus a squared dx is equal to 1 over a times tan inverse of x over a plus c. Remember, tan inverse is the same as arcadient. Hope that you are getting this. Let's have examples now. Examples. Example A, the integral of 1 over x to the 0 plus 1 dx. Let's do it step by step, guys. We start assuming x to be tan u, because here is 1 the square root of 1, that is 1. As I told you, we take the square root of this number times tangent ratio. Okay? Now, dx is going to be sec squared u du. Okay? Now, let's continue here. We have 1 over tan squared x plus 1 times sec squared x dx. This is going to be 1 plus tan square. 1 plus tan square gives sec square. That's why here is the integral of sec squared x by, is here x or u? Here is u, needs to be u. And you are differentiating with respect to u, you must be u. Tan squared of u plus 1 gives sec squared of u dx. And this is the integral is to simplify this of the u. And this is u plus c. Because here we have u and x is a function of u, we need to make u a function of x. Okay? Now, u must be tan inverse of x. In other words, the integral of 1 over x to the 0 plus 1 dx is the arctangent of x plus c. I do want to make a I don't make it not a perfect square. Example B. Integral 1 over x to the 0 plus 3 dx. As I told you, we take the square root of this number. Okay? We assume x to be the square root of this number, that is root 3 times the tangent of u, where dx is going to be the square root of 3 times the derivative of tangent, which is the square of u du. Now, the integral becomes 1 over the square root of 3 tan u square plus 3 times the square root of 3 sec squared u du. This is the integral root 3 times sec squared of u du divided by, what is the square of root 3? That is 3 tan square of u plus 3 du. Here we have root 3 sec squared u du divided by, let's now factorize by 3 here, because 3 is common. Factorize by 3, we have tan square u plus 1. Okay. We are going to take root 3 over 3 out of integral sign, so that it will be written here. Let's have root 3 over 3. The integral here is sec squared u by tangent squared u plus 1, that is sec squared du. This is going to be, let's simplify this and this. We have root 3 over 3 times the integral of du. This is root 3 over 3 times u plus a. Okay. What is here? According to this, u is gonna be, we need to divide root 3 here, the tangent inverse of x by root 3. So the integral of 1 by x squared plus 3 dx is equal to root 3 over 3 times tangent of x by the square root of 3 plus a constant of integration. Keep watching because I believe in you. I'm learning from you as you're watching. Notice your time here is very important, and we are starting toward a victory. We need to have the second example. Let's talk to the next example. We have the integral, that is example about where the numerator is bigger than the denominator. Here is x for 3 minus 2 divided by x squared plus 1 dx. Okay. Now, as you see, the whole numerator is 3 while that of the denominator is 2. Here we need to do long division. Okay. Let's now go. Having x for 3 minus 2 divided by x squared plus 1. To have x for 3 here, we need to put here x. This x times this is going to be minus x for 3. This x times 1, that is minus x. Okay. Here we have minus x minus 2. And this is less than this. That's why we are going to stop from here. Okay? The integral becomes, we need to have this x dx minus, because here is minus, take minus out, the integral of x plus 2 by x squared plus 1 dx. What is this? The integral of x is x squared over 2 minus, I'm going to say this, I'm going to take the integral of x over x squared plus 2 plus 1 plus 2 here, let me like this, the integral of x by x square plus 1 dx plus the integral of 2 by x squared plus 1 dx. Look, this one, taking the derivative of this will give us 2 times the numerator. That's why I can use, let me put this A and this B to make this question well understood. Okay. We have the integral of x by x squared plus 1 dx. We are going to use this up. Okay? Write u b x squared plus 1. Du is going to be the derivative of this is 2x dx. What we need is dx. It's going to be du over 2x. And the integral becomes x by u times du over 2x. Simplify this x and this one. Because here is 2, we need to take 2 out. This is a half of the integral 1 over u du. And this is a half of ln u plus c. And you know what u is? U was x squared plus 1. Now, the integral of x by x squared plus 1 dx is going to be a half of ln of x squared plus 1 plus c. This is a. It's a. What about b? b is the integral of 2 by x squared plus 1 dx. As we saw, we take these 2 out of the integral sign, take 2 out to stay with 1 over x squared plus 1 dx. We saw it here. This integral is the arctangent of x. That's why this is going to be 2 times arctangent of x plus c. Now, the integral of x power 3 minus 2 divided by x squared plus 1 dx. This is equal to, we need to take this. Here is x squared over 2. This minus times this. We have minus 1 over 2 times the natural log of x squared plus 1. The second one is this. Is here term? Yes. Plus 2 times arctangent of x squared plus 1. Sorry, of x instead of x squared plus 1. Then you add a constant of integration. Right now, let me leave you exercise before ending this live. I want you to evaluate these integrals that are given here. A is the integral of x squared minus 2 divided by x squared minus x plus x squared minus 2 dx. B is about x squared plus 1 divided by 6x minus 9 x squared dx. The next one is C, integral of x power 5 divided by x power 3 minus a power 3 dx. And D is the integral of x squared plus 1 by x squared plus 7x plus 12 dx. Guys, I want you to try all of these questions. Hope that you enjoy the course. Before leaving this live, I want you guys to subscribe to the channel. Make sure that you liked. Any comment you have, any question you have, please write it in the comment section. If you have any question among the equipment here that face you, please let us know it so that next time we are working on it. Thank you very much. May God help you and fill you blessings. Goodbye. See you next time.